Okay, here are the results that I took earlier. I took these numbers by watching the video again and reading the numbers as best as I could as I put the pieces of paper over the light sensor. And I've put these into a Google Sheet, that's Google's online spreadsheet service. And I'm going to try and draw a graph of these now by highlighting these numbers here and clicking Insert Chart. Now you'll see Google gives me here what it thinks is a line chart. It describes this as a line chart, but you'll see that it's been drawn with straight sections of line, and I'm sure that your teacher at school will tell you always that you are not to do a join the dots type graph like that. Through a shape like this we would draw a smooth curve, and we can get the spreadsheet to do that for us if we change this line chart to a scatter chart there. Okay, now it's put the points on for us, and you can see that's definitely a curve. Now I'm going to get it to draw a line by going here to Customize and then to Series and scrolling down to put Trend Line. So it will draw the best fit line it can. Now you'll see at first it tries to draw a straight line, which is obviously not right, so we want it to draw the best fit curve. This relationship is called an exponential relationship, so I'm going to ask it to draw an exponential graph for me. And there you can see we get a much better fit. Now we can download this graph, but before we do that I'm going to make it look a little bit more like real graph paper and make it easier to read from by adding in some more lines. To do that I have to go right down to the bottom to where it says Grid Lines. Here it says the vertical axis. Well, if you notice, our vertical axis is only marked every 500, and it would be quite useful to have marks every 100. So this here where it says major grid line, that's the ones it's already given me, and I'm going to ask it first to put those in black so that they'll stand out when I add some more. And I'm going to ask it here underneath to add some minor grid lines. Now I want to divide each of those sections into 5 lots of 100. But that doesn't mean I need 5 lines, that means I need 4 more lines in there. And then I'm going to ask it to make those lines a different colour so that the dark lines stand out a bit better. And then I can do the same on the horizontal axis. Now the horizontal axis only goes up in every 2, but again I'm going to split it into, if I split that into 10 sections, we'll be able to read at least in 0.2 of a sheet. So I'll first of all make those major grid lines black, and then to divide those sections into 10 I need to add 9 lines, and I'll ask it to make those that pale colour so that they stand out. And now you'll see we've got something that looks like a real piece of graph paper. It's got grid lines on it that will allow us to read off the numbers on that graph, and we can download it by clicking on the 3 dots here. You can download it either as an image file or as a PDF. I'm not going to bother with the scalable vectors because we're not going to do anything fancy with it. So you can download it here as PDF, or you can download it as an image to copy into another file. Now I've got this one downloaded here, so let's have a look at it. Now you can see that the line doesn't go through all of the points, but you know that when you draw a best fit line you don't go through all the points necessarily, you just do the best trend line you can, going close to all of the points, as close as possible to the points. And if we look at the shape of this, this is a classic exponential graph in that the change is not by the same number of looks every time I add a sheet of paper, but it's by the same percentage of what we started with every time we add a piece of paper, and I'll show you what I mean by that. If you look here at 1500, that's where the line starts. Now half of 1500 is 750, so let's look at where we get to 750. There's 750 there, and if we read across you'll see remarkably that's exactly 2 sheets of paper needed to reduce the intensity of light by half. Now, that was just complete coincidence. I didn't expect that. I thought we might get something like 1.2 sheets of paper or 2.4 sheets of paper. Magically, with the type of paper I had, it just turns out to be a complete number of sheets. But what's really important here is that if we're at 750 at this point, well, half of that is 375. And if I go to where 375 is, well, there's 300 and there's 400. So I want to be 3/4 of the way across that square. And look, it's another exactly 2 sheets. Now, that's how half thickness works. In this case, the half thickness of my paper is exactly 2 sheets. That means every time I add 2 sheets, I will halve the intensity of radiation. Now, probably yours isn't going to be an exact number of sheets. You might have different paper from me. You're certainly likely to have different starting light conditions than I had. Your numbers will be different, but the pattern should be the same. Get your Google spreadsheet to draw a graph like this. Look at what number you're starting at, and then look at how many bits of paper, even if it's a 1.3 or not a whole number of sheets of paper, find out how many sheets of paper it takes to reduce that to exactly half, and then watch for the next exactly half, and you should find that it's always the same number of sheets of paper. This is exactly the same as what real scientists would do investigating absorption by certain materials. The only difference in our experiment is that we haven't actually got a thickness down here, because we don't have what we need at home to measure the thickness of those sheets of paper. So instead of measuring our thickness in millimeters or micrometers or nanometers, as a scientist, a real scientist would have down here at the bottom on the axis, we've had to use the number of sheets of paper. It doesn't change the relationship. We've got exactly the same kind of graph. We've still got the same understanding and we can still see the same pattern. We've just used different units.